changes on average relative to the change in another quantity. So we define rate of change as being change in y over change in x. Okay? Another way you will see that written is down here below. That triangle is the Greek symbol delta, and that means change in. So instead of us writing out the words change in, we just have to put delta y over delta x, and that's implied to be change in y over change in x. So let's go ahead and look at an example here. It says the table shows the temperature of a solution after it has been removed from a heat source. Find the rate of change in temperature for the solution. So if you notice, it gives us a lot of values, okay? We don't want to necessarily find the rate of change between every one of those values. I just want the rate of change from the start to the finish. So this is what I'm going to do. Okay, I'm going to take 118.4 minus 143.6. And I'm going to divide that by, what do you think? 12 minus 0. So all I need to do now is calculate that. So if I take 118.4 minus 143.6, you should end up getting negative, is it 25.2? Yep. Okay, and I'm going to divide that by 12. Now if you go ahead and calculate that, you're going to get negative 2.1. Okay, and so now I need to come up with a label. And my label is going to be degrees Celsius per minute. Now if you're wondering how could you figure out that label, let's look at the top. What's the label of the top here? That's Celsius, right? Those refer to degrees Celsius. On the bottom, that's minutes. And so that's how you determine your labels. You just figure out what's the label of the top, what's the label of the bottom. Okay, so that's where it's degrees Celsius per minute. So with that in mind, I want you to do this one for me. Okay, the graph at the right shows the number of gallons of water in a swimming pool as it is being filled. At what rate is the pool being filled? Because you're probably going to use those numbers.
It's telling you what it is, Dwight. That's really fast. Celsius? Really fast water filling. Gallon pressure.
You've used the 108 twice. Go ahead and write that down, and then you've used the 108 twice.
Yeah, do you want us to do the label on this?
I don't think you're going to be able to do the label anyway.
Gosh, I forgot my decimal. You don't need one?
Oh, do we?
Awesome.
We,
I make the right decimal. Oh. Is that wrong?
Did I do it?
You have to do 3 minus.
I use your calculator too.
Oh, it's 3.
You don't
Dang!
use 8 at all. It's 7.
I kind of need to use that too.
Kill me.
She says it right up there, but
I know it is. Yeah, I would say that. That's cool.
Are you going to answer?
Are you gonna answer?
oh,
And the answer is 36. Okay? How you get 36, guys? You need to be paying attention. Okay? How you get 36, you've got two values here. This is what they tell you. So all you're going to do is do exactly what we did on the page before. 252 minus 108 divided by 7 minus 3. Okay?
Oh.
Does it matter what
I thought it was
This is-
7,250.
That's what I
No.
thought too.
That's why I was
3.
confused on
Oh, that's
No,
why.
it was 3.
This is.
Okay, so let's look.
Does it matter which number? Because I took
No,
108
yours
minus.
is fine. Find the average rate of change of the percent of total music sales for both CDs and downloads from 2001 to 2008. Compare the rates. So we're going to do CDs, and then we're going to do downloads. Okay? So let's go ahead and look at CDs. Where do I start with CDs? 89.2%, and then I go to 77.8. So I'm going to take 77.8 minus 89.2. Now the question is, what do you divide by? Well, I go from 2008 to 2001. Okay, so those are the values that you use. And so I need somebody to go ahead and calculate that for
Why
me,
don't you use from 2001 to
because 77.8 correlates to that. What?
1.628.
Negative 1.628. Somebody else get that?
Yeah.
Okay, so let's figure out what the label is. What is the label for the 77.8 and the 89.2? What is that? Those are percents, right? What's the label for 2001 and 2008? Those are years. So what this means is that you have a drop of 1.628% per year. So that means it's dropping. Negative's usually bad. Okay. Let's go ahead and look at the downloads. What does the downloads do? What do I do? 12.8 minus 0.2 divided by what?
2008.
2008 minus 2001. Okay. So what does that come out to be? 1.8. So that would be the same label. So let's compare those. Look at what's happened. Okay, now eventually this is in 2008, so you can imagine in 2012 if the trend were to continue, what's going to happen with those two lines? They're going to mate, okay, because your downloads are obviously skyrocketing with the advent of, you've got your iPod, you've got your MP3 players, you've got your iPad, you got your Kindle, okay, same things like that. So your downloads are increasing. CDs, people aren't buying them anymore. Okay, they're buying the electronic versions. So anyway, let's go ahead and look at this. It says, in 2002, 23,142 students applied to a college and 34,689 students applied to a university. In 2010, 29,563 students applied to the same college and 36,107 applied to the same university. Determine the average rate of change in applicants for both schools from 2002 to 2010. So what I'm going to do is I'm going to go ahead and label the colleges with the purple. Okay, and I'm going to label the university with the blue so that I can kind of keep those numbers straight. So let's go ahead and find the college. The college, I'm going to take 29,563, subtract 23,142, and I'm going to divide that by 2010 minus 2002. So basically I'm dividing it by 8, right? Okay, what do I get? 802.63. What would the label be? Students per year. Nice job. Okay, let's look at the blue. 36,107 minus 34,689 divided by your 2010 minus 2002. What do you get there? Just 177.25?
Yep.
Okay. Did you get, it was at 802.63, is that one right?
Yeah.
Okay. So why do you think that is? Why do you think you're so much higher for a college than a university? Cheaper. No, it kind of depends. Okay. In this case, you're having more of a change in a college as opposed to more in a change in a university. Sometimes your universities have a little more stricter requirements to get in as opposed to some of your colleges. Okay, especially UNL. At UNL they require your 4 years of math. They have all these requirements like ACT scores. Where generally some of your smaller colleges, like your York and your Doane and your Concordia, they don't necessarily have those 4-year requirements on math and like those ACT scores. They look at the individual. okay, without that, so, anyway. All right, so let's go and talk about slope. This is something you've talked about, it's nothing new. Slope, remember, is rise over run. It's the same as the rate of change. So really, we've pretty much talked about slope this entire lesson. We just haven't said we're talking about slope. So remember, slope is change in y over change in x again. So once again, nothing new. If I were you, I would make sure that you get down this formula right here. Okay? Because that's pretty much the standard formula for slope. y2 minus y1 over x2 minus x1. So we're going to look at a few examples of this, and that'll be it then for today. So y2 minus 1 over x2 minus x1. So it says find the slope of the line that passes through. So this is all I'm going to do. I'm going to subtract my y's. So in this case, 5 minus 3. Okay, so 5 minus 3. In this case, divided by the x's, which is 2 minus negative 4. 2 over 6, which we know is 1/3. Okay, it's pretty much the same thing we were doing in the graphs. We're subtracting the y's divided by the x's. With that in mind, I need you to do this one for me on your expressions. Let's go. -8, 11, and 24, -9 will be a fraction. There should be a slash.
Oh, crap.
Oh,
Dang it.
I meant first.
I suddenly.
that one.
You're gonna get like a line, is my answer.
Just keep pushing.
Because I
Yeah, I already
used the wrong-
sent it. Good luck. What'd you say?
It froze up.
Like J or something? Doesn't matter.
Yeah, it was negative 9 minus
Take
11
9
minus
minus.
How do you do?
Well, you try and do this. See, my negative sign.
What is
froze
your
up.
That's how you do a fraction.
No, that's negative.
I don't.
Oh, you don't have a negative, sorry.
I
I
don't.
don't know what you're trying to do.
Okay, we should be finishing up.
Why did
You gotta push it again.
Give me a J.
Yeah.
Push that.
Still J.
No, push it again so it gets right.
Okay, I'm going to give you about 10 seconds.
Wait, I can't.
Travis screwed up.
Sorry, I didn't screw push. Just push number 1.
I didn't send it in as a fraction.
There you are, -5/8.
That's what I got.
My bad.
Okay, so that's what we mean with the slash. Okay, so you should have gotten -5/8. Okay, so,
J
all right, -9 minus 11 over 24 minus -8. So you should have gotten -20 over 32. Okay, let's go ahead and look at this one. It says find the slope of each line shown. So when you're finding the slope of a graph, you're looking for 2 points that it specifically goes through that you can see. And so if you look at this, it goes through this point here. It also goes through this point here. So I'm looking for rise over run. Okay, so my rise, what do I do to get to this point to this point? I go what? Down 3. And I go right 2. So my slope there would be -3/2. With that in mind, I want you to do the bottom one. Enter it in. Okay. Now that one, I'll be honest with you, I only see about 2 points it goes through. And those are the points far away. What?
There we go.
Did you figure out the instruction?
Nope, I just pushed buttons and it came
Gotcha.
I did that so
Michelle, we should have a team meeting too.
Alrighty, gonna give you about 10 seconds, and then we're gonna finish up.
We're gonna take a team meeting too.
How do you know where to go? Over that way or down first? Oh, that's right.
Okay, let's go.
Great.
What do you mean?
Just push send, it doesn't.
Okay, the answer is 3/8. Okay, now, let's go ahead and look at this, folks. This isn't tough stuff, all right? I mean, you've got to be able to read graphs. You did this in algebra. Here's a point here. Here's a point here. Let's count. We always do rise over run first. That's your vertical. So if you notice here, I go up 2, 4, 6. Why is it 2? Because each of those tick marks is 2s. Okay? Over from here to here. That is 16. How do I know? -8 to +8. Once again, 2, 4, 6, 8, 10, 12, 14, 16. Rise over run gives me 3/8. Okay, you've got to be able to do this. I mean, that's the bottom line. Here's your assignment, 79 through 80, 9 through 28. Okay?